Hi everyone, welcome back. We're going to be starting 2.3, complex numbers. The essential question for today is, what are complex and imaginary numbers and what operations can be used with them? So the content that we're learning today isn't really that difficult, it's just a little more abstract in a way, because we're going to be working with, for the first time ever, imaginary numbers. So the first thing that I want you guys to actually write into your notes after all of those set up, go ahead and write imaginary unit. So the imaginary unit is actually going to be represented by the letter I. And what the letter I actually represents in terms of the imaginary numbers is that I is the same thing as the square root of -1. So now in Algebra 2, we're telling you, hey, you can actually take the square root of a negative number. But now this results in this weird little idea that there's an imaginary unit. So because I is equal to square root of -1, I squared, or I times I, so I squared equals I times I, actually is equal to -1. Okay? So we're going to be working with all of this information in order to add, subtract, and multiply these type of numbers. These numbers are actually going to be referred to as complex numbers. And complex numbers are basically a combination of the regular constants that you guys are used to and imaginary numbers. So in standard form, let me draw an arrow right there, standard form, it will be written in the form A plus BI. A is just the regular constant, and B is representing the number or constant in front of the imaginary number. Okay? In terms of pure imaginary, so pure imaginary, these are the numbers that are only imaginary. There's no real number attached to it. And these are represented by BI. Okay? Now we're going to go ahead and see some examples and try to make sense of all of this imaginary numbers. First thing that we're actually going to do is add and subtract imaginary numbers, or complex numbers to be more precise, because we're incorporating real numbers into this as well. So adding, subtracting complex numbers, the basic rule is that if you're adding two different sets of complex numbers, you have A plus BI, and then the other one would be different variables, so C plus DI, what you do is you're actually combining like terms. So in this case, you're going to be combining A and C, my two real numbers, and then BI with DI, my pure imaginary numbers. So with this, you end up combining A plus C, and then you have B plus D, all in front of I. Okay? Let's go ahead and do one example of that. So example 1. We're going to have 5 plus 3i, put that in parentheses, plus 7 minus 2i. So in this first example, our real numbers are 5 and 7, and our imaginary numbers are 3i and -2i. I'm going to go ahead and put these with the like terms, so 5 plus 7, and then plus 3 minus 2i. 5 plus 7, simple enough, 12. 3 minus 2, just 1, so 1i. So just like in working with variables, you don't need to write the 1. You are allowed to just write 12 plus I. Same exact thing. And that would be our resulting complex number after adding these two complex numbers. All right? So that's the first set of notes that I want. Next is multiplication of complex numbers. So multiplying complex numbers. Multiplying actually can get a little tricky. There's a lot of different ways to multiply, because you have your binomials, you have your single terms being multiplied together, and then you have your square root of negative numbers. So let's go and practice that one first. So example 2, I'm going to have the square root of -25 times the square root of -16. Now in the past we would have said, okay, that's impossible, we can't take the square root of a negative number. In terms of real numbers, that's true. However, we want to make sure that we're working now in the imaginary sense. So because of this, we're going to take the square root of negative 25. Square root of 25, easy enough, is 5. But the square root of a negative number also gives us I. Okay. Likewise, over here, I have the square root of negative 16, which is going to come out as 4I. Now, if you need kind of like a visual sense of this, 25, or negative 25, I mean, you can think of it as 5 times 5 and I times I, which is why we end up taking out 5 and an I. Alright, so when you multiply these, you multiply your two coefficients, 5 and 4. So here we would get 20. You get I and I, which is I squared. I squared actually becomes negative 1, just as I mentioned earlier. So this becomes 20 times negative 1, simplifying it down to negative 20. Okay? So multiplying these two square roots of negative numbers, we ended up with a negative answer. The final one that I want to go over for today, let's see if I can squeeze it in. Example 3, we're going to multiply two binomials together. So 4 plus I times 3 minus I. Now you may use the box method, you may use whatever multiplying strategy you want. It's pretty much the same way that you're used to. Only difference is that now we have the imaginary number. So here we have 4 and I, we have 3, negative I. So here I have 12, 3I, negative 4I, and then negative I squared. So checking for like terms, the first one I have is 12, no like terms for that one. Then I have negative 4 and 3I. Subtracting those together, I get negative I. Then finally, I have negative I squared. Now again, we don't keep negative I squared as is. We need to change I squared to a negative 1. So what I have is 12 minus I minus negative 1. Notice that I have a double negative. That negative didn't go anywhere. But now, because I have a double negative, it will become positive. So I'm going to combine these two. Can't actually do that, so it's 12 minus I plus 1. Only like terms here are 12 and positive 1, which means I have 13 minus I. So by multiplying these two binomials, I ended up with another complex number, 13 minus I. Alright, so after working with all of these imaginary numbers, if you're confused in any way at all, please replay the video, look through your notes, and rewind as needed. Other than that, have a great weekend, and we'll keep working with imaginary numbers next week.